All right, welcome everyone. Today we are really excited to have Garrick West here to talk to us about debugging rules. To get started, Garrick, I can just hand it off to you if you want to introduce yourself and take it away.
Sure. I can give myself a quick intro here. My name is Garrick West. I'm a consultant with Industrial Logic. Uh, Shorthand for that, I've spent a number of years as a developer doing a lot of lean and XP type of technical practices, both as a developer and as a technical coach. And it's something that I love doing and I love sharing things about. And today, what I have is something that I think is kind of a little bit of a diamond in the rough, or maybe kind of a lost gem in terms of books that I stumbled over probably in the mid 2000s. I believe, if I remember, it was published in like 2006. And it's one of those things that when people ask me specifically for, like, what would you want a new developer who's starting out, like what books would you say, you've come out of boot camp or self-taught or whatever, it's your first week on the job as a professional developer, what books would you give someone and say, hey, when you're done panicking and go home at night, here's something to let your mind spin on that's not specifically about work. The first one is actually the Pragmatic Programmer, and the second one is this book that we'll be seeing the cover of fairly soon, the Debugging Rules book. And it's one of those strange things about the nature of software development. As I said, I'm not the source of these rules. Everything out of here is pretty much from the book, with the exception of some personal anecdotes and descriptions that I inject. But we'll go through and we'll be talking about the rules and going looking at some of the highlighting points, kind of like, well, here's the rule. It's like, well, what does that rule mean? And kind of like the supporting information for it and why it's there. But debugging in general is one of those things, particularly in the software world, that it happens. We're confronted with problems, and they are emerging out in terms of some sort of a conflict of the natural world or the code world, of whatever type of problem that we're trying to solve, and something's wrong. And this inherently has been called a bug. Um, Interestingly enough, Thomas Edison talked about bugs in electrical circuits. And of course, we have here the picture of the what I like to consider the most famous bug in the world from the Harvard Mark II. This is in the Smithsonian, by the way. This is a page out of the notebook where they found a moth in the relay. So if you can stretch back your mind and think about computing history back when things were wired and vacuum tubes and all sorts of more antiquated technology than the silicon chip, that was where this came from, and it became a little bit more common in terms of being referenced. And a bug or debugging kind of became a standard reference in the software world eventually. Um, so this book itself, the whole concept, everything put together by the author David Aggins, is 9 rules and this collection of war stories. And so my idea going through that was to introduce them to you, put the ideas out there, and then in terms of an activity and time available, I thought it would be fun to share some of the things, our audience response, what people think about the rules, of course. And it's always fun to hear different people's personal perspectives and war stories, because we've all got proverbial war stories about particularly interesting bugs. Um, the fun thing about this too, you'll notice on the cover, although I will keep talking about this, and a lot of the examples will be going back to something that is software or hardware or technology related. This doesn't have to be that. One of the examples coming up is a matter of finding something wrong in the physical world. A possibility of finding a leak or something like that. This is a lot of the same. These methods and these rules can be applied to the conceptual as well as the physical world. So without further ado, And this is the one, although I'm happy to make the slide deck available in terms of uh, 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 materials afterwards. If there's anything that you want to take a screenshot of for the top level, this is it. The 9 rules themselves. Um, Understand the system, make it fail, quit thinking and look, divide and conquer, change one thing at a time, keep an audit trail, check the plug, get a fresh view, and then technically, in a way, one of my favorites. So if I were to put my favorites, they'd be in a different order. Um, but one of my top favorites is the impact of the last one that I've personally been bitten by. That if you didn't fix it, it ain't fixed. Which I think is why that was left there as kind of a summary point. Um, so, um, taking a look one at a time. Number one, understanding the system. This is the first rule for a reason. Um, if you really want to get down to it and get cathartic and reflective about what you know and your space in the world and the problem that you're trying to solve, um, if you're having trouble understanding the system that you're trying to fix a bug in, that's going to be your biggest stumbling block potentially. In some cases, there's obvious ways to start to address this. Um, Read the manual. Um, the joke is, and especially for a lot of men, the manual is the thing that you throw away so that you can get to the parts in order to start assembling and doing stuff. But especially for a complex enough system, even if you think that you're in the right spot or looking for something, the old thing, when all else fails, read the manual. That can actually be a really good place to start when you're talking about understanding the system. Um, and when you do this, one of the important factors is to read everything in depth. If you think it's like, oh, I understand this, and you're skimming pages, slow down, go back and take a look. Particularly something that's possibly in the area around what you're trying to solve. And that gets back to knowing the fundamentals. Um, how should something fail? How should something not fail? Based on your understanding of the system, is the failure you're seeing something you would expect to happen? Um, Knowing the roadmap, understanding how the system is divided up. So, in terms of what's going on, if a car, the car's not starting. Okay, well, what do you know about the car in terms of a system? Well, there's an electrical system, there's a fuel system. Um, does it have fuel? Is the engine even getting close to turning over? Does it go click click click? Does it imply that the electrical system isn't there? You know, if you can't even turn on the radio, perhaps you shouldn't be concerned about whether or not you have a full tank of gas. Um, Knowing the roadmap, understanding your tools. Um, this can be interesting, especially if you go and you think about it in terms of software debugging. There's a little bit of a two-edged sword, especially for those of us that are XP fans. We like to spend as little time as possible in the debugger, but every once in a while, especially when you're getting into trying to dig into something, sometimes some of the best things to do can be using some of those tools, even if you don't reach for them that often. So, understanding those tools, and last but not least, look up details. This is a fun one. I know personally I've bumped into in other times, especially like for software systems. It's like you fire something off, you're running something in a certain mode or a certain command, and you're thinking, oh, well, the default for this is blank, right? Well, blank is on by default, or blank is off by default. And you think that when you've thrown into another environment or you're doing something else and you're going along, and all of a sudden something's not behaving as you expect, you're expecting it to be operating in one mode when it's actually operating in another mode. The irony of the bug is human error in terms of how it was started. Well, you didn't start it with the correct flag. You've got Mac OS, but you just decided to start playing around with plant UML, and surprise, surprise, you don't have an X server. So of course it's not going to pop up the GUI. So use Homebrew and fire up an X server, that sort of thing. So that's number one with all the summary points, understanding the system. Once you've done that, as you've probably seen a number of times, getting that good understanding, When you've got a bug, make it fail, which sounds easy. Uh, but if you don't do it right, it becomes really frustrating. Um, some classifications of bugs we'll end up talking about a little later. They get really problematic if they're intermittent. Um, I know personally speaking, that's one of my most feared categories of bugs is when someone reports something and says, "Well, this only happens intermittently." It's like, uh-oh. Um, and with any luck, they might be wrong. But in order to make something fail, you kind of got to start at the beginning and kill off some of your assumptions of what's going on. Even if it seems wasteful, if you can go back, reset, restart, go in, start at the beginning, and make sure that you can make it fail. And once you've made it fail once, make sure you can do that again. Make sure that you understand what you have configured, what's going on, that you're repeatedly can make something fail. So the concept here is a little bit of an acronym. It's a little bit of yin and yang. Is the notion of what we want to do is to stimulate the failure. Wonderful, nice pot of coffee there. And that is to say, you're feeding in the same thing, the same information, the same state, the same data that puts the system in a failure state. What you don't want to do is simulate the failure and do something that's approximate to what the error condition is, because then you can end up looking at or getting what's not really a fix. Um, as I mentioned earlier, if you end up in the situation where you're dealing with something that's intermittent, you've got to find the uncontrolled condition. Whatever that might be, you need to start to narrow down and get closer and closer and closer and figure it out. And you can find what's the uncontrolled condition here. Um, Sometimes, as nasty as this is, there's the T word that could be the source of it, threading issue or a timing issue. Those two, in terms of really nasty bugs, and you can get closer to figuring that out by finding what the uncontrolled factor is, narrowing it down. If you're still fighting, this can get really important and get really interesting. Record everything. Um, I don't like looking through logs, but in a lot of cases, if you're trying to track particularly an intermittent bug, turning on or cranking up logging or adding in logging can save your life. Um, and you start looking at, well, what does the log look like when this fails? And what does the log look like when this doesn't fail? You start looking at timings, that sort of stuff. Um, so apart from that, that being said, talking about timing, um, don't trust statistics too much. That old idea that correlation is not causation. Um, Take some notes, but sometimes if you're taking a look at that and you're starting to take a look at seeing if you've got a correlation, you always want to hold it lightly. It's like, okay, so well, this is a possible, but let's keep trying to prove it guilty, as it were, instead of assuming that that's what's going on. Also, um, and this is a famous one. A lot of times when we're hit with a bug, first off, this is the famous words. It's like, well, that can't possibly happen. It's like, no, that can happen. There's ways to make that happen. You might not be thinking about right now, but particularly if you're seeing them, something's causing that. So getting yourself out of that mindset in terms of trying to figure out how to make it fail, um, that's one thing that can kind of help you keep an open mind in terms of coming up with different hypotheses and trying different things. And last but not least, this was kind of one of the interesting concepts out of the books that I really like. And over the years, I recognized, hey, I've actually done that with this team or something, which is never throw away a debugging tool. So if you come up with something and you've gone in and you spent 45 minutes, an hour and a half, and you crafted in the world of code maybe some bizarre data loading, intermittent error reproducing integration test, which is ugly as hell. You don't necessarily have to put it in your code base, but you don't necessarily have to destroy it either. Um, it might be very helpful to hang on to. In some cases, these can go into like a side branch or a side project or something to have some sort of exploratory, or if there's something in the world of hey, we've got we came across this problem, and so we hung on to some of the tests that we did around this, but it's in another project. That's totally fine. Just you don't have to make it a necessarily a first class citizen of your code base or something, but if you come up with a useful tool, don't throw it away. In the software world, things like that are actually typically pretty cheap to keep around. Number three, this is where we can also get tripped up. I feel a lot of times, at least personally as a programmer. Quit thinking and look. You can think of thousands of reasons for a failure, but you really need to see the cause of it. You have to actually see it doing what's been described by someone else. Um, seeing the blue screen of death or seeing the error message yourself, um, because you don't want to fix what's not broken, because you've got, what, I'll bet someone else, you can describe a problem and say, oh, you know what, I've been concerned about the XYZ subsystem here, or the way that we're dealing with the request queue. I'll bet it's related to the request queue, and so you go off and you end up being accusatory with the system, as opposed to actually leaving the innocent alone and seeing what's happening. Um, and you want to see the details, particularly. Don't just inspect stuff at a high level. If you can confirm, take a look at secondary indicators, anything like that, dig in. And as you're going along, that's where building instrumentation in comes in handy. I mentioned earlier, like source code debuggers, but also logging status messages. If you've got something in your system that kind of works as a proverbial smoke alarm, possibly for some application, you might have a top level error catch that says, hey, if I see something that blows all the way to the top of the stack, log it out here. Or maybe I want to highlight if it's something that can't happen, like an out of memory message. Or if I see something in there and it's a Java world or something, and it's, network or something like that. It's like, I want to know if there's a networking problem, because that's going to be potentially just device or environment specific. That may be among the classification of bugs that you can hammer away in your world, and I just can't reproduce that. Oh yeah, I forgot the new features of Mac OS. I wasn't necessarily celebrating that, but thanks, Apple. And so also, if you can't build instrumentation in, you can always add instrumentation on. Analyzers, scopes, wire sharks, one of my favorite examples. Um, Anyone here ever suffered from a slow leak in a tire? I don't know if it's been too close to construction sites or whatever, but I've had far too many in my life than I'd like to admit. And the wonderful folks in my neck of the woods at a local company called Les Schwab, what they'll do, whether you're their customer or not, they'll go in and they'll check out the tire for you. And they use this really advanced method where they take the tire off, they take some water with a little bit of soap in it, and they run the tire through, and then they look for bubbles. That's simple. You know, Classic example of adding on instrumentation. You didn't have to, do anything advanced. You didn't need, to put under an X-ray or something like that. But, something as simple as soap bubbles. If you've got some sort of analog or something in that you can add on as instrumentation, especially if it's quick, works easy, great. Um, to me, stuff like Wireshark might be a thing of last resort, but sometimes those will put an end to any question. It's just like, well, why is it behaving like this? I don't know. Do we know what headers are being sent from the server? Well, how do we find that out? We can find it out damn quick with Wireshark, can't we? There you go. Inspect the HTTP traffic, that sort of thing. So this is one. In terms of investigating, one thing that's really helpful is just telling yourself not to be afraid to dive in. This could be tough if you're under pressure. But recognize that, if something's broken, you just kind of crack things open and figure out what's going on. And once you've done that, when you're trying to come up with ideas of what to look for or what to rule out, um, as a side note, watch out for Heisenberg. Um, I don't directly mean Walter White here, but you could say Heisenbugs. Um, in some cases, and I know that I've hit this, you go in, you've added a bunch of logging statements to figure out what's going on, and all of a sudden the problem goes away. Why did the problem go away when I added logging statements? I've seen it a bunch of times. I'm sure a number of you have too. Well, we slowed it down, didn't we? You know, we drug out and we hid the race condition. Um, so keep an eye out for those, that parts of your investigation or parts of your tooling, be aware, sometimes can skew your results. And last but not least, um, ideally you want to guess only to focus the search, kind of like throwing out a hypothesis. It's like, I suspect it's X, Y, and Z. Okay, what's your proof? Come up with an experiment, validate it. It's like, well, let's put some instrumentations around this class. Let's try swapping out the persistence layer and see if it makes a difference. Sometimes depending on what you're working on, how easy that thing to do. Sometimes stuff like that is dead simple. Sometimes that's going to take a while. Can we deprioritize that in terms of what we want to guess at? So once you've decided to quit thinking and look, you really want to divide and conquer. Oddly enough, your good old friend, the binary search tree, you reduce the problem space, you definitely know what you're not looking for. If you have a client server system and you make the same request with a curl command and it shows up and it's correct, well, it may not be coming from the server. When you look at those things, sometimes what you want to make sure to do is consider the range of the boundaries when you're talking about that. Possibly the size of request. You have something going on with an HTTP request. Is it a big request? Is it a small request? When does this never happen, or when does this only happen? You want to kind of try and figure out which side of the bug you're on. Looking from where your system goes from what you expect to behave from okay to that's messed up. As soon as you can find that, you're going to get a lot closer in to recognizing what you want to zero in on. You want to use easy to spot test patterns. This is a fun one, not necessarily something as relevant today's, but a classic example. If you were doing desktop application development on a system back in the 1980s and you needed to allocate memory in C, you might have developed a good habit of allocating the memory and then writing and filling a repeat of the hex value of BADF00D, so that if you got an error and you took a look at the data that came back, if it said that you read bad food, you know that you had a pointer problem. You read into something that you should not have read into. You allocated it fine. Maybe you allocated that block again for the example of what your program required, but the way you were structuring and the way you're using your memory, you had a pointer issue, and because you got bad food. So test patterns. Also, starting with the bad sometimes can be helpful too. So figuring out where things are broken and working backwards. Got a bad thing displaying on the UI. Okay, let's go pass into the UI, get into the code. It's like that value is supposed to be coming from this call over here. What if we just run that and make the call? Was it something that the UI did in terms of processing, or was it something actually from the call? Where did things start to go with bad, starting from the bad? Also, as you're going through, sometimes in terms of general behavior, before you get into a bugging situation, fixing the bugs you know about. Because bugs that kick around can obscure other bugs. And so if you build in a habit in terms of maintaining your systems of killing the bugs you know about when they're found, you're going to be in a better situation down the road, because you're less likely to have either made decisions and replicated things that invite bugs, or you're going to be able to more easily avoid when you go and start inspecting things, not getting sidetracked by bug XYZ, which can be a classic problem of going down a rabbit hole trying to fix something. You go and you're fighting for one bug, and then you stumble across another. Not only is that frustrating, it can be a little demotivating too. Last but not least, in terms of divide and conquer, one of the best things in the example from the book was to fix the noise first, aka stop the bleeding. Um, if the smoke alarm is chirping, um, take the batteries out. Of course, those only go off and they only break at 3 o'clock in the night. And they're only out of batteries because you didn't pay attention and change all the batteries when the clocks got moved ahead. So in a way, that's your fault as well as mine, because I've done the same thing. But that concept of, figuring out how to make the bleeding stop, even if it's inelegant. If we do XYZ, there's, a problem in production and, users are getting this error. Okay, so we don't know how to fix it now. Can we temporarily put something in that disables that, or says a pop-up that says, sorry, this is unavailable at the moment? Fix that bleeding, stop the screaming, stop the upset customers that are calling in. Fix that noise first, and possibly in some cases, give yourself some time. And that, to an extent, that gets thrown in here because that's another aspect of dividing and conquering the problem at a high level. Number 5. This is where pairing or ensemble programming can really help out, because when you solo, the temptation to just go in and say, oh, I want to change these two things at once because you've got like a long update cycle or something in order to do a deploy or do this or to get something built. It can be easily tempting to want to change two things at a time. Well, the problem with that is which one actually worked. You don't know. And by changing only one thing at a time, classic scientific method, changing one variable at a time, you're going to isolate the key factor. And this can be hard to do, again, if you're under pressure. An example that the book had here talking about dealing with things under pressure, in the event that something is going wrong and you're underwater in a submarine, there is a brass rail. And what submariners are trained to do is to grab that rail when analyzing and dealing with the problem. Because when your hands are on that rail, you're prevented from going off and flipping some switches, or assuming that you want to adjust a gauge or something, and thinking about that before you just go and do something. It may be hard to, in some ways, because that's it. It's easier to do something than it is to keep your hands there and talk about it. That was kind of one of the interesting points that I got out of this book that I'd never seen the perspective of before. When you go through talking about changing one thing at a time, change one test at a time. That maybe if you're doing TDD and something like this, and you've got something, we know from TDD that these types of things can help in some cases. In an ideal situation, these write themselves. I know a number of times I've seen, there's been an error, there's been a bug report, and that it feels, or I would say it feels in your heart that you are 90% of the way of solving it if you can get a unit test that exactly repros that. As soon as you see that red failure, you're like, yes, we're about to kick this thing's butt, whether you are or not. But still, going through and changing one of those at a time as opposed to changing multiple, because you make assumptions, because there's a setup possibly, that can start to get in your own way. You also want to consider, in some cases, doing comparison with a known good. Particularly in a complicated system, if you've got, some sort of process and it does all this stuff and it outputs something at the end. Well, here's the broken one. If we can get an example of a known good, then we can take a look at diffs side by side, possibly literally a diff, and say, okay, what's different? What's in the good one that's not in what we have? And as a side note, on a local project we were on, we found that my team has been on, we found a number of times for complex mobile application that the state of React Native and what was going on with our objects and how things were working, that we could get a better understanding of what we might have missed and be able to correct it by taking a look at some of that state output. Now, that was really gnarly, mind you, but there were a couple of times where it was like, oh, we made an incorrect assumption in terms of our test setup. And we didn't necessarily actually put it in the right state in order to simulate what we wanted to test in terms of driving our behavior. And so there have been a number of minute bugs and minor conditions where we recognized and it hit us smack in the face as soon as we took a look at a comparison between load up some data and just dump it versus go through our test data and take a look at those structures side by side with the diff tool. And it's like, oh, why are we missing this? Why are we missing that? Some of them were easily explained. Others were like, uh-oh, and ended up being the root of our problem. Um, This is a classic. In terms of changing one thing at a time, determine what changed since the last time it worked. Um, you say, well, what might be different? Someone else might say, get blame. So maybe not with torches and pitchforks, but just going through and taking a look at, well, what's different about this from where it was before can help get you on the right track to identifying and, excuse me, narrowing down that investigation space, crossing out the number of hypotheses that you might want to throw out and check. So that's number 5. We're a little over halfway through. Number 6. I laugh here because I've been so bad at this, and there's a part of me that's been tempted to write the author back and say that number 6 should actually be number 2. Because I've noticed over the years that I have been horrible about doing this, even when I find myself in a debugging situation, which is something I'll get to a little later. I've got a couple of add-on slides talking about that. In fact, my joke here, write down, keep an audit trail. As soon as you start realizing you're in a debugging mode, and just, write down what you did. It doesn't have to be electronic. Scratchpad, old habits from my XP days. I've got 3.5-inch 3x5 index cards. A buddy of mine, back when we paired, I had a running joke. His name was Hua. I had a running joke about Hua's infinite index card list of things to do, where he would track notes and do that. And when we got into debugging situations, that was the great thing about it, is that he was actually pretty good about, we tried this, we tried that. Taking notes, very important. Understand that any detail could be an important one. Sometimes what looks like normal input isn't. I'm going back in time and blaming the wonderful folks at Microsoft who in Office replaced standard quotes with Microsoft Smart Quotes, which back in the age of SOAP APIs would make your server choke. And then you've got your customer saying, well, this is exactly what I put in. I put in the XML for the SOAP request that you said would work, and it's not working. And then you look at your logs and you see, yeah, because you're passing me smart quotes. Rant over. Correlate events. That's the other helpful thing with an audit trail. Is like, well, we did this and we did that. We did that. Oh, hang on a second. Did we do blank before we did the other thing? Oh, no, we didn't. Does the code do that? Or in the path that the person who's reported the bug go through, had they set this up this way? Take a look for those. Again, correlation is not causality, but it'll help narrow your search space. Understanding audit trails for design are also good for testing. Version control info, again, can help figure out where to look for bugs, what changed. This is a different flavor of what changed. And then last but not least, you'll have to forgive me because I'm starting and finishing with write it down in terms of keeping a log. As soon as you realize you're doing it, just grab some paper, do something, write it down. Because the number of times you go through and say, wait, didn't we try that already? Well, I don't know. If you wrote it down, you'd know. Number 7. Yeah. Check the plug. Obvious assumptions. The number of times, if anyone here has, of course, seen the classic UK comedy, The IT Crowd. Hello, hello, this is IT. Have you tried turning it off and on again? One of the characters would answer the phone in the first episode. By episode 4, they had a reel-to-reel tape recorder set up so that on the second ring, the IT department phone would pick up, and the pre-recorded course voice of one of the main characters would say, hello, hello, this is IT. Have you tried turning it off and on again? And then it would pause and say, uh-huh, uh-huh. Okay, we'll give that a try then. Goodbye, and hang up. Also, start at the beginning. Sometimes this is a variation of check the plug. It's like, okay, so even if it seems ridiculous, is it turned on? Do we have, are you connected to VPN? A classic personal experience. We thought it was a major problem and voiced it an entire morning. And it turned out that the reason that things were screwed up on the site was the pair that was looking at the bug that they found had a Chrome plugin turned on that had a little bit of a collision with how our site behaved. And so what looked like an actual production problem could only reproduced on this one developer's machine because of a Chrome plugin they had. Sounds ridiculous. It happens. Last but not least, this gets to be a weird one. Test the tool. If your voltmeter isn't registering correctly on something that you're not sure is working, make sure your volt reader reads correctly on something that is working. Seems obvious. A lot of times people won't think about it. You'll just grab the tool because, well, I'm trying to fix the problem right now. I got this tool that I know can help me. The tool's going to get in your way if it's not actually working. Number 8, get a fresh view. There's some fun ones in here, and I'll get them to a little better explanation. Ask for fresh insights. Go explain your problem to someone or something else, rubber duck debugging. And if you can, as you go through, if you know someone who's more of an expert than you, tap expertise. I'm not great with blank. This bug has come up. Maybe I'll ask someone who has a little more depth of knowledge in this. Listen to the voice of experience. In some cases, it might help you. That expertise might tell you, well, don't start there. If they say that can't happen, well, ask them what could cause it. Help in general, we know nowadays. In 2006, when this is written, this wasn't as relevant, but help is all around. You've got coworkers, customer support, the web, of course, ready to ask. Our good old friends in Stack Overflow until AI possibly puts them out of business, as everyone threatens, but we'll see. And when you do this, don't be proud. No one's perfect. Bugs happen. If you can take pride in getting rid of the bug, that's great. But, there's no reason to be sheepish about saying, I don't have the right tool set to necessarily do this. A little bit of that agile pattern, in my opinion, of ask for help. And here's one of my favorites out of this section, and something that I know I've been bad at in the past. And if you only take a few things out of this talk, here's one recommendation that I would suggest, which is report symptoms, not theories. This gets hard to do, especially when we as developers love to share everything that we know about what's going on. You come in and you say, I'm seeing this and we've got this error and it looks like that. And then you start saying, and I tried this and I tried that. You're actually kind of poisoning the well in terms of getting new perspectives. So only reporting symptoms initially when you're going to someone else, going to this expert over here, or this the voice of experience, whoever that is, or even the rubber duck. Only reporting symptoms will help remove any bias that they might incorrectly form. I mean, not incorrectly, that's not their fault, but they may accidentally form a bias if you give them theories to start building on. And last but not least, realize you don't have to be sure. Um, if there's data that's confusing or seems like it shouldn't matter because that can't happen, still share it. Um, Having more information than less is always helpful when you're trying to get a fresh view. And number 9, last but not least, uh, if you didn't fix it, it ain't fixed. Um, and then I put this in, of course, as a joke quote that it seems like it's working now, said giving comfort to nobody ever. Last on this, check that it's really fixed. And don't assume that the change you made was the only change that was needed. This becomes an interesting problem when you start dealing with different environments. If you have a development environment versus stage of production, the change that you made may be perfect for it works on my box, but the dev and test mode may assume something that helped it work. There may be some new type of data, some minor configuration, or some update that might be required in another environment in order to actually fix it elsewhere. And you need to see that it's fixed, not just the proverbial works on my box, but it's out into production. We can't repro this anymore. The bug's dead. And while you do that, um, check that it's really your fix that fixed it. Um, if you can compare two versions, that's helpful. But there's nothing more frustrating than knowing that you didn't reproduce it correctly and that your fix may have fixed a bug, but not the bug. So, for example, if you had something that was causing, say a user error to appear on the screen, and you go through and it works on your machine and everything works okay, but the root cause of that happened to be some sort of a production environment timeout, and all you did was address what the user saw, you may still actually have a bug because what you thought you fixed in terms of that process may have not been the actual thing that was happening. So a little bit of a weird one, but determining that your fix is really what fixed it becomes relevant. Um, this is this is the favorite. Uh, know that it never just goes away by itself. Those intermittent bugs, something that, well, it only happens under load. That's fine. The bug's still there. It's not going to go away on its own. And that brings back the whole, original make it fail approach. If you need to ship something under pressure, sometimes one of the things that can help with this, if you know where a bug will happen, is to set a trap for it, where you do some sort of a workaround, implement some additional instrumentation or logging, or if it's rare enough, maybe it's like, hey, we fire an alarm off that says, we saw this bug again and it happened here. And then you go back and figure out, okay, was this a business impact? Is this something that we have to correct? Or the fact that we lost XYZ in terms of processing this data is noise in the system? It depends. Depends on what's going on, and the level of importance. And then, of course, obviously, you really want to make sure that you fix the cause. Um, Fixing the symptom, the whole, stop the noise, stop the screaming. Um, that example with the smoke alarm, while I joke at 3 o'clock in the morning, that hasn't fixed the problem that your smoke detector is not working. You fix the symptom. that your smoke detector isn't beeping at 3 o'clock in the morning. You still have a broken smoke detector. So you always want to make sure that you can go through and fix the cause. Yeah, one of the examples I hear the joke, hey, if we just turn off the monitoring, we won't get any of these annoying 2 a.m. alerts in the system. And last but not least, out of all of these is fix the process. It's kind of a deep philosophical one. In some cases, you will go along and you will look at a bug and you'll say, well, okay, this is kind of dumb, but we're having this because our process says that we have to do X, Y, and Z. Okay, why do we have to do an X, Y, Z? Is there a better way to do the process? Classic example, possibly synchronous versus asynchronous. If you've got timeouts going in some system, maybe the correct thing to do is stop running something synchronously and start building a whole, ticketing process, little mini tickets that says, I've submitted this request and I'll come back and I'll check it later. Because when it goes on for 5 seconds, even if it only happens under severe load, even if it only happens at the end of the month when someone's running reports, whatever it is, if the process is still there that's causing the problem, it's not going to help. So if necessary, dig in and see if there's something in the process that's inviting bugs. So a couple of ways that I've thought about getting this socialized and applying it. This was kind of fun at the Agile camp that we had back in last October. So I had originally done a version of this talk last summer for the Seattle Crafters meetup. And what I decided to do was say, okay, there's 9 rules. Each of these rules has, typically like 3 to 7 or 8 different examples, different points to ponder. And I thought, why don't I put these up? Because I didn't have them totally memorized. I made some marks on the back. And then we went around and I said, so what rule would you want to read the manual for? Well, that goes for understand the system. You see all these things. So basically, made a game out of that. This is something that I'm probably going to inflict on other folks at other open spaces because it's fun to do. It's interactive and it kind of introduces this book and these concepts. Gets people talking about debugging and all that sort of fun stuff. And last but not least, without necessarily formalizing it, because I know that there is a way of doing mob RPG where there's different roles. Maybe at a minimum, even if it's not formally folks doing something like mob RPG, if you thought about adding an exterminator role the next time you're mobbing. So who's driving? Who might be called out as a navigator? Then ask, does someone want to take a time being the exterminator and call out, hey, are we in a debugging mode right now? Oh, we are. That exterminator can start taking some notes. And someone say, we've been in debugging mode for about 5 minutes now. We've been in debugging mode for 10 minutes now. We've had a few, we've tried about 3 or 4 different things. What do we think about this? Can we bring up those debugging rules again? What are we missing? Do we understand the system? Are we stopping thinking and are we taking a look? I've got a log going here. I like this idea. I would be thrilled to hear if people want to give it a try. Ping me, email, social media, whatever. Give me some feedback if this is a viable thing. And last but not least, that's basically the end of everything that I have. And I wanted to give the opportunity to answer questions, feedback, comments in the time that we have left.
Awesome. Thank you, Garrick. Yeah, and if anyone has a question, feel free, you can just unmute and ask, or if you'd rather type, you can do that as well.
Oh, And if you like, let me go back to the rules slide. Hey, I got the right one on the first try.
Mhm.
I have a question for Garrick. You'd mentioned that the book was written in 2006 and it
Yeah.
still very much applies today. Looking at it through the lens of 2023, would there be anything that you think you would change about it?
Because of the way it's structured, I think it kind of stands as a general process because it doesn't really, I mean, a lot of the stories and examples and stuff. I mean, I mentioned the tire example and, the whole, this is the submarine analogy about, being in the mode of problem solving, is that I think a lot of it still really holds no matter what the work medium is or the problem medium. So I think my only thing is that I would probably put I would reorder this in that I would probably put keep an audit trail at number one. I hate to say it. And maybe that's just because I've been so bad, because I've like I said, I've read this book, I've read it a couple times now, I've done the presentations, I think they're really helpful, but I have trouble getting myself to really to really do that and leverage at times um to be able to. So I think that's my only gripe, and that's just because it's my own personal fault. Would be to say step one, keep a trail, keep an audit list, keep an audit trail, write down what you're doing, write down what you've tried.
Yeah.
Because at that point, the worst in the worst situation, you've got an incredibly short list of something that you just throw away because it's scrap paper. Or sorry, in the best case scenario. In the worst case scenario, you end up being like there's a detective from a BBC series that my wife got me hooked on called oh gosh, I'm trying to remember. It's like Desert Murders or something like that. It's set in the Caribbean, and it's has Danny John Jules from Red Dwarf, isn't it? But one of the detectives, he never keeps a notebook, and he's constantly writing crap down on scraps of paper, and it's just kind of one of his comic effects. And I could see that in a worst case scenario, if you're not planning to do that, you'd end up with like potentially a mass of papers or something if you don't do it often enough. But so yeah, that and then again the fine point on number 8 for getting a fresh view, not poisoning the well when you go and open the scope of who's looking at the problem, so to speak. To me, that's almost I think that would almost be worthwhile of revising the way number 8 is written, and they're all short and sweet rules.
Mhm.
But changing number 8 to like get a fresh view, but don't contribute bias, possibly. That is important enough to be like called out as a modification of rule number 8.
That's awesome. Thank you. Anybody else have any questions?
Or any favorite war stories to share? Of course, throughout the talk, I snuck in most of my favorites. That XML one was a particular axe to grind because at the time I was a rabid Linux fan, and it was just any ammunition that I could have to complain at Microsoft was a reason to shake my fist at the cloud. So
I have probably a thought on every single one of these. On your I like them, love them. Understand the system. I think you need to narrow the scope on that one because I actually tell people you need to understand what the software is supposed to be doing to be able to understand where it went wrong. Because some folks will just get stuck in the debugger and they're just tracing, and they never seem to realize that they took a wrong turn, 3 steps back. So it's almost like understanding the scenario, understanding the usage case or whatever, rather than trying to say, understand the system. And I'm like, oh my God, no, I can't.
I understand the whole thing. Yeah, that's a good point.
um, the audit trail, I don't know whether I drove Brett crazy with this or not, but he commented on it. I will actually leave things that I have tried commented out in the code
Okay.
so that we can actually switch back easily by uncommenting and recommenting, and it creates your
Yes.
audit for you.
Yes. That's a good example. Thank you. I like that one. When you've gone through, and I have done that. I've done that a couple
Yeah,
times as well,
because we were
particularly with
pairing.
TDD.
Yeah, because I mean, we were pairing, and we could actually say, yeah, we tried that, but we didn't
Mhm.
try, and then we can make a variation on it.
Yep. Yeah. Yeah. No, that's a good
You
point.
know, another one, and I was in an airline where I would watch people fix things. One is often threading or multi-threaded issues require inspection of the code. It's really nigh impossible to set up a test that will actually just show those. So you
Oh.
have to be looking at the code with respect of what will happen in a multi-threaded environment with the way this is set up. Okay.
That's interesting. Yeah.
Um,
Huh.
think of another one that, yeah, the quit thinking. A lot of good advice because they're all good. I think I'm going to stop there. I think I have a meeting I'm supposed to be running to.
Okay.
Thank
Oops.
you, Garrick. It was a great talk.
No
Looks
problem.
like a really good book. It's hard to find those gems that people,
Yeah.
know.
And that was the funny thing. I don't remember how or where I stumbled across it, but I had done it, and back in the mid 2000s, I shared it with my team, and the author used to have you could like send away and get a free poster, and so we had like an 8 by half by 11 poster up on our development room wall with all the rules. So
Very cool.
yeah,
Right.
thanks.
Thanks, Mike. Take care.
Cool.
Yeah, I think this is great. I think so. I reached out to Garrick about this before. I did 2 different trainings, and there was a mix of more senior and junior developers in the trainings. And in two different cases, when we went over in the beginning, kind of getting some information from the group on what they wanted to work on, one of the things that came up was improving their debugging skills. So I hadn't even read this yet, but based on Garrick's glowing recommendation, I said, I haven't read this yet, but it comes highly regarded and recommended this book. So I'm looking forward to reading it.
Cool. Yeah, that's the fun thing. It's an easy read too, because you just kind of breeze through it. It's it's not like you're reading code or you're reading theory. It's a lot of good stories.
All right. Anything else? All right. Well, I guess if not, we can wrap it up. Thank you, Garrick, for joining us. This was really awesome. If you want to share the slide deck with us, I can post it, or you can post it as a comment in Meetup to the meeting if you'd like.
Okay. Yeah, if I can. There's not a ton of images, so it shouldn't be too large if I just do it as an attachment. Cool.
Yeah, I think that should be fine.
All right.
Excellent.
Thank you very much, everyone.
Great. Thanks, everyone. Thanks for coming.
Cheers.
Take care.